Hi, this is Leen Weijers at Liberty Oilfield Services, talking to you today about fracture model calibration. Typically a first step in an economics or fracture modeling, reservoir analysis or calibration. Here's a challenge for typical modeling considerations. Typically in fracture growth modeling, there are too many parameters to use in the model, and too many parameters with significant uncertainty. So I've listed here a variety of parameters and called them by the level of uncertainty. And of course we want to have parameters in the green area where we know them pretty well and understand how they work. That's typically, for a large number of parameters, not the case. So what we can do in the field is do additional measurement kind of beyond what is normal on a typical frac project. Maybe do improved measurements such as defits, core testing, things like that, measuring closure in neighboring layers. And with these improved measurements, we can eliminate some of the uncertainties in parameters. We can further eliminate these uncertainties by conducting fracture diagnostics. And from fracture diagnostics, we can get both pressure and maybe fracture dimensions, and maybe determine what has happened down at the level of the wellbore with respect to effective perf clusters. And with that information, we can train a model and further eliminate some of these uncertainties associated with fracture model calibration. Let me show you an example of how this works. What I'm showing here on the left is a net pressure match where we're matching the net pressure to observed net pressure. Calibrated net pressure is in yellow and the model net pressure is in white. And we've got a reasonable net pressure match that was achieved by using classical fracture modeling physics with tip effects and multiple fractures. And with that we achieve a fracture geometry that looks something like the picture on the right. Now we do fracture diagnostics, we do microseismic mapping, and you can see that the microseismic fracture geometry is much more confined and much longer than the fracture that we created with the fracture model exercise that we went through. So what we need to do now is exchange some of the tip effects and multiple fractures for composite layering effects with decoupling effects to then come to a similar net pressure match, but that now also matches the overall fracture geometry that we see from microseismic mapping. In a nutshell, that's how model calibration works. And now we have a fracture model that is much more robust to determine what happens when we conduct other fracture design changes and how the model is sensitive to some of these changes. That's where we combine with fracture model calibration, we combine or eliminate some of the shortcomings of typical fracture models is that they don't always provide a full physical understanding. With the shortcomings of direct fracture diagnostics, that they're not predictive. When we combine these two particular approaches, we create calibrated models that now can more realistically predict how fractures will grow for alternative frac designs. Now this is something that at Liberty that's in our blood and that we do all the time. Fracture model calibration is a key step to determine actual frac design sensitivities and move to a full modeling sequence with reservoir analysis and economics. No one in the industry has more experience with fracture model calibration than Liberty's tech team. If you want to put us to work on your fracture model calibration project, visit us at libertyfrac.com.